Okay, Mursal, I think this is recording. I am going to do problem 23 first. I'm going to talk about domain and range in general. Domain, I think you know this, but just in case, is basically, you could call it the allowed values of x. What can x equal for that function? Likewise, the range is the allowed values of y. So if we saw the graph of a function, let's say that's the graph of the function, my domain would be everything from this value of x here to this value of x there, and my range would go from this low value of y. I'm not sure what higher value of y is. Let's say that's the highest value of y. Then that would be my domain and range for this particular function where I'm cutting it off at here and here. Oftentimes our domain and range can be, if it's a cubic function, for example, generally speaking, you might have something like that. Well, I didn't draw that very well, but the assumption is that this is continuing to go out in the positive x direction and continuing to go out in the negative x direction, and it's certainly going down to negative infinity in the y direction and to positive infinity. So there, our domain and range, if we use what's this called, interval notation, our domain would be from negative infinity to positive infinity. Our range would be from negative infinity to positive infinity. That's a big blah blah. That might not have even been necessary to say that stuff. But let's go ahead and look at this particular problem. This function is x squared minus 6. That's in the family of functions that would, if it was just, I'm not drawing very well today, but if that was f of x equals x squared, that's that function. That's the graph of it. It should have the vertex at the origin, and I kind of missed it. What about this function? What about this function here? Well, it's almost the same function. The only thing that's happened is it's been shifted down vertically by 6. Meaning it's now, this vertex is the point 0 in x and negative 6 in y. What's the domain of this function? We can plug into it any value of x, all the way from negative infinity to positive infinity. What about the range? Well, the range, those are the values of y we can get. We can't get any values of y below negative 6. So our range goes from negative 6 all the way up to positive infinity, because we can see that y can get bigger and bigger and bigger as we let x get more positive or more negative. So the range is from negative 6 to positive infinity. That is problem 23. Now so I should tell you what the answer is, but you should see it. It is answer C is the correct answer. And the difference between, just to make another little point, the difference between a bracket, well, in fact, I'm wrong. This should be bracketed because it can equal negative 6. So the correct answer there is answer choice D. We use a bracket when it can include that number, and y can include negative 6. It can include that. By convention, you could say we never put brackets to signify negative infinity or positive infinity. We always use parentheses there. So hopefully that is good with problem 23. Let's go to problem 24. And you can, if you need more clarification about any of this, just get back in touch with me. All right, problem 24. Oy, oy, oy. Again, it's a domain and range issue. Let's think about, this is what's called a piecewise function. It's got two pieces to it. One is the line 3x plus 2. That's got a steep slope. And that only is good for negative values of x. And then we switch over to 3x plus 6, same slope, but it jumps up in the in the y direction. From y equals 2 to y equals 6. In fact, really, technically, I should draw a hole there because it didn't quite reach that value. It didn't quite reach x equals 0. Then it switches over to this function, and let's think about our domain and range. Because the domain of the second function is x is greater than or equal to 0, that means it actually can reach that specific point. So we don't have to put a hole there. We can make that solid. Let's think about domain and range. Well, domain is the values of x that are allowed. This guy keeps going. I can stick in any negative value of x and the function still works. I can stick in any positive value of y and the function still works. So my domain is from negative infinity to positive infinity. Let's think about y values. Well, down here, as I put in a more negative value of x, I'm getting a more negative value of y. Here, as I put in a more positive value of x, I'm getting a more positive value of y. And in fact, I can get down to negative infinity for y. I can get negative infinity. Somewhere over here, I'm going to write positive infinity. But I'm missing some values of x, of y. I'm missing those values in there of y. I got close to, but didn't quite reach positive 2. And that's because of that hole there. I didn't quite reach positive 2 for y. So I have to put a parentheses there. And then I also want to include, which is why you do the U, I think of it as throwing stuff into a bowl. Everything sticks when I throw stuff into that bowl, as opposed to that notation where this is an and. It's got to be both in this part and in this part to be able to use this notation. Oh, that's a frowny face. All right. So, where do I pick up in my range? I dropped off at 2, that's there, and I pick up again at 6, but it includes 6. So I'm going to put a bracket there, and I go from 6, and then the range continues, continuously all the way up to infinity. So that's my domain and range there, and that is problem 24, and the correct answer there is, looks like it's answer choice, oh no, crud. It's answer choice B, yeah. So that is answer choice B. Okay, then let's go to 25. And hold on a second, let me. All right. My dog is barking in the background there. All right, so 25 is so now we're talking about a different topic, really. Even functions and odd functions. I'm going to talk about even functions first. I'm going to talk about both even functions and odd functions. I'm not sure how deep you're getting into this topic, so I'm going to kind of keep it brief. An even function is symmetric. Oops. I think that does get another M in there. Symmetric about the y-axis. So that's to say, if I have a point there, I've got to have a point there. That's reflected about the y-axis. So a point here implies I got to have a point there. If I have a point here, I have to have a point there. Every point, one way to think of it is you go directly at the y-axis a certain distance, and then you keep going that same distance on the other side of the y-axis. Sometimes that's written, you could say if this was the point AB, let me think about this point here. It went just as far in the negative x direction as this point went in the positive x direction. So instead of this having a coordinate, an x-coordinate of a, it's got an x-coordinate of negative a, and it's in the same place in the y direction. So that y-coordinate is the same as that y-coordinate, and consequently I could write that point like that. I guess I'm going to finish talking about this problem, and then just for the heck of it, I'm going to go ahead and talk about odd functions, seeing as that might be something you're supposed to know as well. If you have the point negative 6 comma 5, negative 6 fifths, and comma 8, if that's one point and it's symmetric about the y-axis, which is what it means when it's an even function, that's going to be, let's say that's our point negative 6 fifths comma 8, and that's the point we're talking about, then I must have a point over there, symmetric about the y-axis. My x-coordinate just switches, the sign switches, so that's got to be 6 over 5, and my y-coordinate is just going to be 8. Same y-coordinate. So that's a point symmetric. That, if it's an even function, that's an additional point that the function would have. And so that's our answer, and that is answer choice E. Just for the heck of it, I'm going to talk about odd functions. Odd functions are a little different. Odd functions are symmetric about the origin. So we'll make up a problem similar to this one. Let's say it's an odd function. And it doesn't matter what point you pick. Let's say it's the point 2, 3. So we got to come up with another point. An odd function does this. If this is one point on the odd function, then the other point, then an other point goes directly at the origin and keeps going the same distance on the other side of the origin. So that says that if this is one point, another point would be down here.